Hello everyone. I welcome you all to my online classes. This is on Maths Corner. Here today our topic is Introduction to Three-Dimensional Geometry. In this exercise we shall discuss the very introduction of the 3D. All the octants in the in this model, this is the first octant, we can say the first corner which is visible to us. Okay, three planes, first plane, second plane, third plane. Okay, so after first rotating this way, this is the second, three planes, combination of three planes together, this is the second octant rotating. Next we have the third octant. Okay, the combination of three planes rotating again, this is the fourth octant, the combination of three planes. After this we come to fifth octant, this is the fifth octant. Thereafter we have the sixth octant. Next we have seventh octant. Lastly we have eighth octants. Okay, so all the octants, they are represented by this model. Okay, beautifully we have explained, we have seen the octant system. In two-dimensional plane, if we take 2 points as p x1 y1 and q x2 y2, then distance between p and q, which is written like this, we find, we have the formula square root of x2 minus x1 its whole square plus y2 minus y1 its whole square. Similarly, we have the distance between 2 points in space. In three-dimensional space, the coordinates of point P, they are x1, y1, z1, and coordinates of the point Q, suppose they are x2, y2, z2, then the distance between P and Q, this is written like this, square root of x2 minus x1 its whole square plus y2 minus y1 whole square plus z2 minus z1 its whole square. Today we shall discuss the questions of exercise 12.3. The name of the chapter is Introduction to Three-Dimensional Geometry for the students of class 11. So let us start now. The topic of the day is section formula. We shall discuss the section formula as well as the questions in connection with section formula. With the help of the questions of the exercise, let us try to understand the topic. The very first question of the exercise 12.3 is find the coordinates of the point which divides the line segment joining the points minus 2, 3, 5 and 1, minus 4, 6 in the ratio 2 ratio 3 internally, second part 2 ratio 3 externally. So let us proceed. Suppose we are given here the point, first point is A, its coordinates are minus 2, 3, 5. This is point B, its coordinates are 1, minus 4, 6 as they are given here. Now joining these 2 points, okay, now what is the question? Find the coordinates of the point which divides the line segment joining the points. Suppose this is the required point. We name this as P and A, B, C. Suppose these are the coordinates. Now, what is the ratio? Internally, 2 ratio 3. So, what we do? We multiply this 2 with the coordinates of point B. 3 will be multiplied here with the coordinates of point A. Okay, how we write here? The value of A will be 2 will be multiplied with 1, 2 into 1 plus symbol. 3 will be multiplied with minus 2, 3 into minus 2 divide 2 plus 3. Similarly, for B, B will be equal to 2 will be multiplied with minus 4, 2 into minus 4 plus symbol. 3 will be multiplied here with 3, 3 into 3 divide again 2 plus 3. C is equal to 2 will be multiplied with 6, 2 into 6 plus 3 will be multiplied with 5, 3 into 5 divide 2 plus 3. So solving this, we have 2, 3 into 2 6 minus 6 upon 2 plus 3 is 5. 2 minus 6 is minus 4 upon 5 is equal to B is equal to 2 into minus 4 is minus 8 plus 3 into 3 9 divide 5, that is 1 upon 5. Here this is 6 into 2 12, 5 into 3 15 divide 5, this is equal to 27 divide 5. So the coordinates of point P, they are A, B, C, and we have got the answer. The values of A and A, B and C, they are minus 4 upon 5, 1 upon 5, 27 upon 5. So this way, find the coordinates of the point which divides the line segment joining the points this point and this point in the ratio 2:3 internally. So we have got the answer. These are the coordinates of point P internally. Now when we solve the second part, this point divides in the ratios 2:3, the same ratio, but in place of internally we are given the word is externally. So nothing is more difference. In case of externally, we just write this 3 equal to minus 3, right? So in the denominator this becomes minus 3, minus 3, minus 3 everywhere, right? So here also this is minus 3, minus 3 everywhere. We change 3 equal to minus 3. Now what happens accordingly? There is a change. 2 minus minus plus 6, 6 plus 2 8, 6 plus 2 this becomes 8 plus 8, and in the denominator 2 minus 3 is minus 1, so minus 1. So finally we have minus 8, and B becomes minus 8, this is minus 9, and in the denominator this is minus 1. So minus 17 divide minus 1, this becomes plus 17. Lastly 2 into 6 12, 5 into 3 15, minus 15. Denominator this is minus 1. 12 minus 15 minus 3 upon minus 1, that is 3. So P, A, B, C, the coordinates are minus 8, 17, 3. Externally word, externally mean we just changed this plus 3 into minus 3. Now we shall go to question number 2. Question number 2. Given that point P coordinates are 3, 2, minus 4, point Q coordinates are 5, 4, minus 6, and point R coordinates are 9, 8, minus 10. P, Q, R, they are collinear. This is given. Find the ratio in which Q divides PR. So again, suppose we have the line PR, PR, and this is the point Q. We don't know whether this is internally dividing or externally dividing. So points of P, coordinates of P are 3, 2, minus 4, and R coordinates are 9, 8, minus 10, and the coordinates of Q are 5, 4, minus 6. We suppose this Q divides PR in the ratio of K ratio 1. So again the same process. We multiply this way. Here this will be multiplied. So 5 will be equal to K into 9. K into 9 plus 1 into 3 divide K plus 1. Right? Similarly, 4 will be equal to K into 8 plus 1 into 2 divide K plus 1. Third time, this minus 6 is equal to K into minus 10 plus 1 into minus 4 divide K plus 1. Right? Now we proceed. This becomes 5K plus 5 is equal to 9K plus 3. So this gives us 9K minus 5K becomes 4K is equal to 5 minus 3 is equal to 5 minus 3 is equal to 2. So this gives us K is equal to 1 upon 2. So we have got the answer. Find the ratio in which Q divides. So K value is 1 upon 2. So we say Q divides PR in the ratio of 1 ratio 2. 1 ratio 2. That too internally. Why internally? Because the value of K is positive. Now forward this step and this step to verify, to check whether this is true or not. We put this value, the value of K equal to 1 upon 2 here, and we check whether this is well established or not. Let us try to check now. 4 is equal to K is 1 upon 2. So 8 upon 2 becomes 4 plus 1 plus 2 is 1 into 2 is 2 divide K is 1 upon 2. 1 upon 2 plus 1 3 upon 2. 3 upon 2. So this becomes 4 into 3 upon 2 is equal to 4 plus 2 is 6. So this is 2. 3 into 2 6 is equal to 6. So we have checked that this is true. Similarly for this case also, this will be true. So our result is Q divides PR in the ratio of 1 ratio 2, that too internally. Question number 3. Find the ratio in which the YZ plane divides the line segment formed by joining the points minus 2, 4, 7 and 3, minus 5, 8. Again, any point on YZ plane is of the form in YZ plane x coordinate will be 0, 0 comma b comma c. So we write here that is x coordinate is equal to 0, right? So what we do now, we follow this formula as well as the section formula. We have the 2 points, these are the 2 points, minus 2, 4, 7, second point is 3, minus 5, 8, and this is the YZ plane having the points where it divides the line segment 0, b, c. Suppose the ratio is k ratio 1, right? Again we use the same rule. How? This 0 will be equal to k into 3 plus 1 into minus 2 divide k plus 1. Just we solve this. K plus 1 into 0 cross multiplying. So this is 0 is equal to 3k minus 2. So from here we can see the value of k is 2 upon 3. So we have the answer, required ratio 2 ratio 3. So 2 ratio 3 is the required ratio. Now next question. Question number 4. Using section formula, show that the points A 2, minus 3, 4, B point minus 1, 2, 1 and C 0, 1 upon 3, 2 are collinear. Let us say these 3 points are collinear. How to prove? Using section formula. Suppose we are given here A point is 2, minus 3, 4 and this is the C point. Coordinates are 0, 1 by 3, 2. Here B is the point, minus 1, 2, 1. Suppose B divides the AC line segment in the ratio of k ratio 1. So we find here the value of k, minus 1 is equal to k into 0 plus 1 into 2 divide k plus 1. Similarly this 2 is equal to k into 1 upon 3 plus 1 into minus 3 divide k plus 1. Lastly this 1 is equal to k into 2 plus 1 into 4 divide k plus 1. So from here we can solve further. This becomes minus k minus 1 is equal to k into 0, 0 plus 2. That means k is equal to minus 3, right? Here also we say 2k plus 2 is equal to k upon 3 minus 3. So we can say 2k minus k upon 3, 3 into 2, 6, 6 minus 1, 5k upon 3 is equal to minus 3, minus 2, minus 5. So again we have the value of k is equal to minus 3. Solving last, this becomes k plus 1 is equal to 2k plus 4. So 2k minus 1k is k. 1 minus 4 is equal to minus 3. So we see that in each case the value of k is same. That is, b point divides ab in the ratio of 3 upon 1, 3 ratio 1 externally, because this is minus sign here. Okay, so we say as k is equal to minus 3, so this can be written as 3 divide 1, minus 3 upon 1. So b divides ac externally in the ratio of 3 ratio 1. When we are writing this word externally, then we shall not write minus sign. Okay, so minus sign we are dropping because we are writing the word externally. So what is our answer? b divides ac externally in the ratio of 3 ratio 1. So a b c, these 3 points are collinear, right? So this is the answer to the question, that is we have shown, we have proved. Next question. Question number 5. This is the last question of the exercise. Find the coordinates of the points which trisect the line segment joining the points 4, 2, minus 6 and q 10, minus 16, 6. Bisect mean dividing into two equal parts. Trisect mean dividing into three equal parts. So we have the line segment. Here two cases are there. This is the line segment. We have the three sections of this line. 1, 2 equal sections. Second case, again we have the three sections. This is 1, 2, 3. So we write here P. The coordinates of P are 4, 2, minus 6. Coordinates of Q are 10, minus 16, 6. Here also coordinates of P, they are same, 4, 2, minus 6. Here Q coordinates are 10, minus 16, 6. Right? So we discuss, we solve the question. How? First time, suppose this is the point R. Now what is the ratio? This part is 1 and here we have two parts, 1 ratio 2. So we write section formula we shall use here. Coordinates of R, they are suppose A, B, C. So what is A? A is equal to 1 into 10, 10 plus 2 into 4, 8. Divide 1 plus 2, 3. That is 18 divide 3 is equal to 6. Similarly, B is equal to 1 into minus 16, minus 16 plus 2 into 2, 4. Divide 1 plus 2, 3 is equal to minus 16 plus 4, minus 12 upon 3, minus 4. Similarly, C is equal to 1 into 6, 6 plus 2 into minus 6, minus 12. Divide 1 plus 2, 3. So this is minus 6 upon 3, minus 2. So what is the answer? The coordinates of point R, they are ABC, that is 6 minus 4 minus 2. This is the answer, case 1. Second case, when the point R is here, or we can say PQRS, its coordinates are alpha, beta, gamma. Right? Now again, now this is two parts, 2:1. So we multiply, we use the section formula like this. What is alpha? Alpha is equal to 2 into 10, 20, plus 1 into 4, 4, divide 2 plus 1, 3, 24 upon 3. Okay, 8 into 3, 24. Similarly, beta is equal to 2 into minus 16, minus 32, plus 1 into 2, 2, divide 2 plus 1, 3. This is minus 30, divide 3 is equal to minus 10. Gamma is equal to 2 into 6, 12, plus 1 into minus 6, minus 6, divide 2 plus 1, 3. 12 minus 6 is 6 upon 3, that is equal to 2. So coordinates of point S, alpha, beta, gamma, they are 8, comma, minus 10, comma, 2. So what was the question? Find the coordinates of the points which trisect the line segment joining the points P and Q. So the coordinates of the points, they are 6, comma, minus 4, comma, minus 2 and 8, comma, minus 10, comma, 2. That's all. Thank you very much.